Today's video is on graphing inequalities, solving inequalities, and also compound inequalities. I'm going to do a little bit of review first with some inequalities. You're going to use a open circle for less than or greater than symbols, and you're going to use a closed dot for less than or equal to or greater than or equal to symbols. There are two types of notation we're going to learn. The first notation is called interval notation. It's a way to express our solution using parentheses or brackets. You're going to use parentheses when the dot is open. So parentheses for these symbols, that mean an open dot. And you're going to use brackets for when the dot is closed with the equal to sign underneath. Example, like in number 1, x is greater than or equal to 8. I'm just going to write 8 right here. Since it's equal to, we're going to make a closed dot, and everything greater than it, we draw an arrow. Writing this in interval notation, we're going to start with the lowest part on the left and go to the greatest part. The lowest part is 8, and since it has a closed circle, that's a bracket. And then the biggest number that it goes to, you write infinity because it does not stop. And whenever you see infinity, you always put a parenthesis because you can never have a closed dot on infinity. You can never reach infinity. When we solve inequalities, you're going to follow the same steps as we would solve an equation. However, when you multiply or divide by a negative number, you're going to flip the inequality symbol. Make sure you have that written down. Let's do number 3, solving for v. Just like a normal equation, we would move the constant over. So we're left with 5v greater than 7v minus 18. We would move the variable term over. So we're left with negative 2v is greater than negative 18. Again, we didn't do any subtraction, or excuse me, we didn't do any multiplication or division by a negative, so no reason to flip the sign yet. Hint, hint. Now we're going to divide both sides by a negative coefficient, and doing that will flip your sign, making your final answer v is less than a positive 9. On my number line, I'm going to write 9. Less than is an open circle pointing to the left. Writing this solution in interval notation looks like this. We start on the left side, so the lowest number all the way over here, since that arrow goes on and on, is negative infinity. And the biggest number on the right side is 9. 9 has an open circle, so parenthesis, and infinity will always have a parenthesis next to it. So make sure the number inside your interval notation is smallest number, then the biggest number. Back at this front page, we need to talk about the other type of notation, other than interval notation. It's called set notation. For example, if we want to write x is greater than 5 in set notation, it would look like curly bracket x, big bar, that's going to mean such that, and then you write your example, x is greater than 5, end it with another curly bracket. And this is read as x such that x is less than 5. The reason why we do set notation, it basically just defines your variable, saying that x is what I'm working with, x is my variable, and for all those x's, my answer is everything bigger than 5. Most of you will probably like interval notation better This written as interval notation is 5, and then everything bigger than 5 all goes to infinity. And since there's no equal to sign, it is also parenthesis. Interval notation, a little bit easier. Set notation, it's not too horrible. You just need to know to include the curly brackets and to include the variable at front here and the such that sign. Not too bad. We're going to get to compound inequalities. Compound inequalities are basically two inequalities in the same problem. Notice in our first example here, we have type 1, which is called an OR inequality. OR inequalities point in two different directions. Here is an example, and we're going to write this in interval notation, and we're going to write it in set builder. So let's start with interval notation. We're going to do this one first, and then we are going to do this arrow next. Okay, in red it goes negative infinity, and then it goes to the biggest number, which is 4, bracket, because of the closed dot. And then what you need to include in between before you get to the other interval is a U. U stands for union, meaning that we're adding these two together. The next interval is going to start at 1, and then it's going to go all the way to infinity, both parentheses, because of the closed circle, and infinity always has a parenthesis with it. Writing this in terms of variables is not too bad. I'm going to start with the orangish one, and that's written as x is less than or equal to set -4. And then since there's another one pointing in the other direction, all you need to write is OR. And that one in blue looks like x is greater than open circle 1. Those are OR inequalities where the graphs point in opposite directions. Go ahead and just solve one of the OR inequalities and graph it. And the way we solve it is just solve both inequalities like you would do normally. Here I'm solving the first one. 3x is less than or equal to 6, dividing both sides by 3 to get x is less than or equal to 2. Then I have OR, and now I'm going to solve my other one just by dividing both sides by 5. So you're left with x is greater than 9. And I didn't have to flip any inequality signs because I didn't multiply or divide by negative. Now let's graph. Less than or equal to 2 looks like here, closed circle pointing this way, and then greater than 9, open circle pointing this way. And again, we know it's OR because they're pointing in opposite directions. Notation looks like this. It starts at negative infinity, and then it stops at 2, bracket. Union, it starts back up for the other line at 9, parenthesis, and then it goes on forever to infinity, parenthesis. The and inequalities could be written as an interval notation. Let's start with interval notation first. Starts at -2, and then it ends at 5. -2 has a closed dot, so it looks like that. And then 5 has an open circle, so it has a parenthesis. The way we write it with a variable, we put the x in the middle, we put the lowest number on the left, and we put the highest number on the right. And they're always are going to have less than signs, but since the -2 has the closed circle right there, we need the equal to sign. -5 has an open circle, so we don't need the equal to sign. the way we read this is that x is between -2 and 5, but including -2. Let's do one example. Let's do number 11 because it has some good stuff going on. This is an and inequality, compound inequality that we have to solve. The way we solve for this type of inequality is we want to end up with m by itself in the middle. Let's start out by moving the -2, the -2 away. And when you add it away to cancel, not only do you have to add it on one side, you have to add it on all three sides. Now this becomes 30 greater than -2 is gone, -10m greater than or equal to, that becomes -5. The last step is to divide not only the middle by -10 to cancel it out, but every side by -10. Since we are dividing by a negative, the same rules apply where we have to flip both signs. Notice how both signs flip. This becomes -3, and this becomes a positive 1/2. The way we graph it is that we put a dot at -3, open circle, and a closed circle at 1/2, and they are connected since it is an and inequality. Finally, lastly, the way we write it in interval notation is that the graph starts at -3, ends at 1/2, but it doesn't include -3, and it does include 1/2. Write down what questions you guys have on today's video. I know I threw a lot at you for compound inequalities. Sorry it went a little bit longer, but have a great night.